Good morning, dear students. Welcome back again with a new lesson of science introduction of acids and bases. Now, how to identify whether the given solution is acid or base? So, without using any chemical, by taste we can easily identify. If it is an acid, it is bitter to taste. Sorry, sour to taste. And if it is base, it is bitter to taste. That is one simple way we can easily identify acids and bases. There are different other ways to identify the acids and bases, and there are certain indicators which will help us to identify whether the different solutions and their nature is acidic or bases. That we'll go through these lessons. So let's start with the introduction of acids and bases. Acids. You all notice that some substances have sweet taste, some are bitter, some are sour, astringent. Lemon, tamarind, vinegar, amla like substances acquire sour taste due to the presence of typical compound in them. Such compounds imparting sour taste are called as acids. Acids are soluble in water and they are corrosive in nature. Animal and plants also possess acids in them. So if they are sour to taste, they are acidic. Acids present in foodstuffs are called as natural acids or carbonic acids. These acids become weak in nature and are called as weak acids. Some acids are strong in nature. They are caustic or inflammatory. For example, sulfuric acid, chemical formula is H2SO4, hydrochloric acid, chemical formula is HCl, nitric acid, chemical formula is HNO3. These acids are called as mineral acids. The skin gets burned when the concentrated solution falls on skin. Similarly, the vapors, if inhaled, can be harmful to health. Strong concentrated acids are converted into the dilute acids by slowly adding them into water. All of a sudden, if you add, it may even catch fire. They are harmful. Such dilute acids are harmful and their corresponding strong acids. Then their corresponding strong acids. If you taste dilute solution of baking soda, you'll find the astringent or you can say bitter taste. Substances having astringent or bitter taste and slippery to touch. Slippery to touch. For example, lime water, chemical formula CaOH the whole twice, that is called as calcium hydroxide also. Baking soda NaHCO3, which we call it as baking soda or sodium bicarbonate. Then caustic soda NaOH, uh, and soap are called as bases. Bases are completely different from acids. Chemically, they are property opposite to that of acids. They are also inflammatory to skin in their concentrated form. We know that the distilled water is tasteless. Water is neither acidic nor basic. Then comes out indicator. Now, what is the use of indicator? This will help us to identify the nature of the substances, whether it is acidic, basic, or neutral. Now, indicator is also of different types. Let's see about the indicator. The substances which are neither acidic nor basic are chemically inert in nature. Touching or tasting of acid or base is very harmful and hence typical indicators are used to recognize them. The substances which change their colors in the presence of acids or bases are called as indicators. Now here various examples of indicators are given here: methyl orange, phenolphthalein, and methyl red. The different colors with the solution will help us to identify the nature of the substances. Apart from that, litmus paper is also used to decide whether the solution is acidic, basic, or neutral. In the laboratory, litmus paper is mainly used to test alkali or base. This paper is made up of extract of lichen plant. It is red or blue colored. The blue litmus paper turns red, dipping into an acid, and red litmus paper turns blue by alkali. Similarly, phenolphthalein, methyl orange, and methyl red are used in laboratory solution form. Methyl orange indicator becomes pink in acid and yellow in alkali. Phenolphthalein remains colorless in acids and becomes pink in alkali. Universal indicator, which are liquid state, change their color in the presence of acids and bases. Now, here it is explained with the help of certain example here. Now, litmus paper, color of the indicator blue, then color of the acid red, and color in alkali blue remains same. Then similarly, litmus paper, if it is red in color, color of the indicator and color of the indicator in acid red remains red and color in alkali blue. Now this is actually the color of the solution which after dipping into the solution we get it. So this will help, these are the indicators which will help us to identify whether the solution is acidic or basic in nature. Their color change will help us to identify. Now domestic indicator. On non-availability of laboratory indicator, natural indicators can be made by using several domestic substances. You must have seen yellow food stain turning red after washing with soap. The color change is the result of chemical reaction between turmeric and the alkaline mineral of soap. Hence, turmeric acts as an indicator. Natural indicators can also be prepared from red cabbage, radish, tomato, and similarly from hibiscus and rose. Now, here some examples are there, and the indicators are there which will help us to identify the nature of the substance, whether it is acidic or basic. Let's see how it will help us to identify whether the solution is acidic or basic. Now, for example, lime juice effect on turmeric paper. So it remains yellow in color. If it remains yellow in color, this gives clear indication that it is acidic in nature. Similarly, if it is lime water, calcium hydroxide, then definitely there will be a color change. That is, the turmeric paper will turn red in color. This will give indication that it is basic in nature. Likewise, this color change will help us to identify the nature of the solution. Likewise, different other substances are there and different indicators give different colors change, and that will help us to identify the nature whether it is acidic or basic. Now, lime juice is there, sour to taste, and definitely it is acidic in nature. So, blue litmus paper turns red in color, will give indication about the acid. So, red litmus will remain red, blue will change into red. Then, phenolphthalein Phenolphthalein is also an indicator which will help us to know the change in color will help us to know whether it is acidic or basic. So, in case of in case of lime juice, the phenolphthalein there is no change. This gives indication about the acidic nature. Then methyl orange for lime juice turns red in color, also gives indication about the acid. Now, if you move ahead with the next solution, that is NH4OH, that is we also called as ammonium hydroxide. Now, since hydroxide is there, OH group is there, gives clear indication it is basic in nature. Basic in nature means red to blue base. So, red litmus paper turns blue in color, which will give indication about the base. So, red litmus paper turns blue color and blue remains blue. In case of phenolphthalein, ammonium hydroxide turns pink in color, whereas in case of methyl orange, it turns yellow in color. All this color change indicates that ammonium hydroxide is basic in nature. The next one is acidic hydrochloric acid. Name itself suggests it is acid, and you can understand what can be the color change. Similarly, nitric acid, HNO3 is acid. So, what can be the possible color change that already we have discussed for the uh, lime juice? So, whatever color change will be there for acids will be same. That is lime juice, hydrochloric acid, nitric acid. They will have the same color change, whereas base will have a same color change. So this will help us to indicate. These are the indicators which will help us to identify the nature of the substances, whether it is acidic or basic in nature. Now, overall, we can say that there is some natural indicators as well as chemical indicators. So you have dealt red litmus, blue litmus paper, phenolphthalein, methyl orange. All these are chemical indicators, artificial indicators. There are also natural indicators. Now, for natural indicators, hibiscus indicator paper, acid turns red, and for base it is green in color. That is the additional information which we are giving it, providing you. So you have to mark it out. I repeat it again. For hibiscus indicator paper, acid red in color, base green color. Rose indicator paper will help us. Acid will be red in color, base green in color. Turmeric indicator paper will help us to know identify acid and bases. Acid it will be yellow, base it will be red in color. Similarly, red cabbage indicator paper will help us to identify acid red, neutral purple, and base will be greenish yellow. So these are some natural indicators which will help us to identify the acid nature of this solution, that is it will be acidic or basic. Now the definition of acid, or how to define acid. Acid is such a substance which gives H plus ions in solution state. For example, HCl dissociates in water solution to form H plus and Cl minus. So hydrochloric acid will give us hydrogen ions and chloride ions. So this will help us to identify that hydrochloric acid is acidic in nature because of the formation of H plus ion. Likewise, some examples of acids, like for example nitric acid, if you put it into the water, nitric acid will dissociate to form H plus and NO3 minus. Sulfuric acid, if you put it into the water, it will dissociate to form 2H plus and SO4 2 minus ion. Again here H plus ion is formed, so which indicates acidic in nature. Similarly, carbonic acid, when you put it into the water, it will form 2H plus and CO3 2 minus. Here H plus formation of H plus indicates that again it is acidic in nature. Our daily diet contains few natural acids. They are mild in nature and hence they are not harmful like mineral acids. A few substances having natural acids organic are given in the following table. For example, vinegar, acidic acid, orange, citric acid, tamarind, tartaric acid, tomato, oxalic acid, curd, lactic acid, lemon, citric acid. So they are very mild, very dilute, and they are not as harmful as mineral acids. The properties of acids. Acids are sour to taste. Acid molecule contains H plus ion as the main constituent. Acid reacts with metal to form. Always a hydrogen gas is given out whenever acid reacts with metal. Then blue litmus paper turns red in color is the test, or you can say it is an indicator which will help us to identify the nature of the acid. Now, it is not necessary that always acids are harmful. The acids which are mild in nature, they are very useful, and sometimes even concentrated acid is also useful. Let's see what are the uses of acids. Acids are used in the production of chemical fertilizer. Acids are used in the production of explosives, oil purification, medicine, dyes, and plants. Hydrochloric acid is used in the preparation of different types of chloride salts. Dilute sulfuric acid is used in batteries, electric cell. Dilute hydrochloric acid is used in sterilization of water. Acid is used in making of white paper from the wood pulp. So these are the various uses of acids. Now concentrated acid and causticity of acid. The distribution of concentrated sulfuric acid in water generates large amount of heat, and therefore the dilution of concentrated acid, it is slowly added to the water. Never add water into the concentrated sulfuric acid. It will produce enormous heat and cause explosion. Alkalis like sodium hydroxide and potassium hydroxide are strong and caustic in nature. The concentrated solution burns skin as a decomposition of proteins in skin. That was all about the acids. Now, uh, we'll discuss about the base next time. So, that's all for today. The remaining part of this lesson we'll discuss in the next video. Till then, have a great day.